See those panels? They're collecting energy from a star way out in space, millions of kilometers from here. Do you know which star? That one!
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Brought to you by the closest star to our planet Earth, the Sun.
Our sun is a star. And like all stars, it's hot.
Like you, Bill?
No, listen, it's really hot. I mean, it's very hot. 6,000 degrees Celsius. That's hot on top of hot. White hot. Way hotter than this goofy special effect. It's big.
How big?
Oh, it's really big. I mean, it's very big. Way bigger than the Earth. Let me put it to you this way. How many Earths do you think would fit inside the sun? 100?
I don't know.
1,000?
I don't know.
1,000,000?
Bill.
Well, you're getting close. If the Earth were this big, this is how many Earths you'd need to fill up that sun. Here we go. You ready?
Yeah.
3, 2, 1. Fooled you. Fooled you. See, I put the sign here. 1.
Bill.
$1.3 million Earths. 1,300,000 Earths. That's because the sun is big.
Just like the airplane that seems small when it's far off in the air, but is really big when you see it close by on the ground, the sun only looks small because it is so far away. In fact, the sun is so large it would take 109 Earths strung end to end to equal its diameter.
That's because the sun is big.
And the sun is hot, reaching temperatures of about 15 million degrees Celsius at its core.
Not only is the sun hot, but almost all the energy that we use comes from the sun. Those cars and trucks are running on fuel made from oil. Now, oil comes from ancient plants, which once got their energy from the sun. And like sidewalk surfers, they get their energy from the sun because the skateboard is driven by the skateboarder's legs. And so he has to eat food, plants and animals, and snack foods, which all got their energy from the sun. And speaking of food, thank you. This pretzel was heated with fuel. It's made from ancient plants. And the wheat, the flour, well, that's a plant. It got its energy from the sun. And this parking ticket, it's written with ink, and the ink is probably a vegetable product. Now, vegetables are plants. Ancient plants, which once got their energy from the sun. And the paper comes from wood, and wood comes from trees. Trees are big plants. All comes from the sun. The sun, you see, it all comes from the sun. Whoa, I better put this back.
Hey, you in the lab coat! Freeze!
Sunshine is hot, right? And we tell how hot things are by using thermometers. You can make a thermometer yourself. It's really easy. Just take a film container and poke a hole in the top. Get an adult to help you. Thanks. Now, put a straw through the hole you just made. Add a little clay to hold it in place. Fill the film container a little more than halfway to the top with water. Add a few drops of food coloring. put the lid back on, and that's it. Now, put your thermometer into a bowl of really hot water. I mean, hot. Be careful with it, because it's really heat. Water can burn. Don't come running to me. Don't come running to me if you burn yourself, because I warned you. Okay? Now, as I was saying, put it into a bowl of really hot water. Be careful.
Ooh, that is hot. I don't think it's working.
This doesn't seem to be working. Doesn't seem to be working.
Uh-huh.
I want to keep working on this experiment, and I'll get back to you in a few minutes.
I can't wait.
The sun is beating down. Can you feel it?
If we were able to travel close to a star, it would look like a huge ball of brilliantly glowing gases.
This is Sunday Edition with Johnny Flair. Sitting in for Johnny Flair is Sunny Day.
You're on. Hey.
Good evening.
All these solar cells collect electricity, and it runs out these wires to your house. As the sun moves across the sky, the solar panels move too. This rock is made of silicon dioxide. It's just like glass. And if we treat it in just the right way, it turns this dark blue color. And these are photovoltaic cells. Photovoltaic. They make electricity from light. The electricity comes out right here. Now, suppose we had a whole bunch of it, like this. Well, then we'd have a lot of electricity, right? Thousands of watts, right from the sun.
Right now the air temperature is like around 45 degrees Celsius, and like it's very hot right now, very hot.
It's called a merengue, and it has apple, peaches, bananas, a little sprinkle of cinnamon, and brown sugar.
I'm gonna put it in a solar oven and cook it.
We're gonna eat it, I guess. I've never cooked anything in a solar oven before. We built it out of cardboard box, aluminum foil.
A solar oven works by like collecting heat like inside the oven, and like it can get like up to more than 100 degrees hot in there.
You can go up to like 300 to 400 degrees.
And then like if you leave like food in there like for like long enough, you can actually cook something in there.
It's called, what's it called again?
On the sun, there are what scientists, maybe scientists like you, call solar flares. Now, this is a flare too, but it's a road flare. Now, a road flare burns at about 1,500 degrees Celsius. A solar flare is 10,000 degrees Celsius. It's hot, really hot.
Careful, Bill.
Oh boy, that is hot.
Careful.
In your house, you use electricity for blending, toasting, heating water, mixing, watching TV, vacuuming, and lighting. All that can add up. You've probably seen an electric meter like this one somewhere around your house. The more power you use, the faster those dials go. They're moving now. But the amount of power that the sun produces compared with the amount of power in your house is huge. Undeniably mega huge. Bigly, hugely huge. The sun makes about 3 quintillion times as much power as you use in your house. That's a million billion times as much. It's enormous. Just think how fast the sun's power meter would spin. The sun's power meter would spin like crazy.
Try new Lucky Stars. Astronomically delicious with yellow suns, white dwarfs, black dwarfs, and red giants.
Frosted Lucky Stars are astronomically delicious.
The sun is a star.
You may never have thought of the sun as being a star, but that's just what it is.
It's a beautiful day at the beach. Surf, sand, sun. But you gotta be careful with the sun. It can damage your skin. That's why we have lotion like this. Sun Protection Factor SPF 15 means it gives you 15 times as much protection as your skin has naturally against the dangerous ultraviolet rays from the sun. All types of skin need some protection. Melanin is in our skin to protect us naturally. The darker your skin is, the more melanin you have. But even people with dark skin often need some protection from the sun's ultraviolet rays. It's not perfect, but it'll help you out. What? What? See how my head is blocking the sun? The same thing's happening with the moon right now. The moon is blocking the sun. Here's how it works. The sun is up there, right?
Hopefully.
Then the moon casts a shadow on the Earth. And that's an eclipse. See the round shadow of the moon? That's all there is to it. It's a solar eclipse. Whoa, look at that thing! Whoa, look! You can see it just perfectly! They laughed at me! They laughed! Ha! Oh, hi. I was just looking at the sun with a pinhole viewer. See, you should never look at the sun directly. You can hurt your eyes. Here's what we have. We've got a white piece of paper taped to this end of the box. Then at this end, we've cut a small hole, see? Then on the outside, taped a piece of aluminum foil. Then using a pin, I poked a small hole. That hole makes an image project through the box onto the paper. And you can observe the sun or a solar eclipse easily. Take a look. See? It works great.
Hey, who turned out the lights?
Oh, ta-da! Okay, I got it.
Oh, ta-da.
I think I figured it out. I figured out why it wasn't working. I think I figured it out.
Okay.
See, when I put the thermometer into the bowl of really hot water, there was an air leak around the clay. But now I think I fixed it. So let's take a look.
You know, it's lost some of the suspense of before.
Like I was saying, it's cool, it's hot, it's science.
The sun gives off a lot of energy. No, listen, I mean a lot of energy. Please consider the following. Here's the Earth. And way over here is the sun. Now you can see that a very small amount of the sun's energy actually hits the Earth. A tiny amount. But that energy is enough to sustain all the living things on Earth, including you, me, kumquats, and bananas. About 1,400 watts of energy land on every square meter of the Earth. That, my friends, is a lot of watts.
What?
Watts. It's enough energy to run 4 blenders on every square meter of the Earth all day, every day. And that's just the energy that hits the Earth. Think how much energy the sun is giving off altogether. It's over 400 septillion watts. That's a trillion watts. And they all come from the sun. Well, thanks for joining me on Consider the...
The sun is the source of energy for all life on Earth.
The sun is the source of energy for every living thing on Earth.
And it is the source of energy for all life on Earth.
Like my costume?
Now, the sun has so much energy because it's so big. It's so big that it has so much gravity, crushes in on itself. It's so much pressure that it makes matter, stuff, fuse together in a sort of continuous explosion.
The sun gets its energy from continuous explosions.
I'm doing a little experiment with the sun. Get a hold of some binoculars and cover up one of the lenses. Then aim them directly up towards the sun. Put a white piece of paper underneath, and look here, you got the image of the sun. And that little tiny dot right there, that's a sunspot, which are like slightly cooler areas of the sun. Now, this is a filthy experiment, but never, ever, ever look directly at the sun, because you could go blind. But hey, these sunspots sure are cool.
Looks like the sun could use a little spot remover. I don't think that would work. You can't remove sunspots. Sunspots occur in cycles, about every 11 years. We're due for another cycle in the year 2005. So I'll be spotting you then. When the sunspot cycle. Get it? Spotting you sunspots? Get it? Sunspots, spotting you? I'll be spotting you during the next...
My name is Karen Harvey. I'm a solar astronomer. And as the name implies, I study the sun. The light is caught by this mirror, reflected up to this mirror, and passes down through the window to our instruments in the observing room. The sun is a huge ball of gas, with nuclear explosions going on constantly. This is an image of the sun in the white light, or the visible part of the spectrum of the sun. If you look carefully, you can see small structures on the sun called sunspots. These are darker, cooler areas with very high magnetic field. In fact, this spot right here is about the size of the Earth, so that gives you some idea of just how big the sun really is compared to the size of the Earth. The sun is very important to study because it affects all life on Earth. Without it, we couldn't live here.
Ah! Hey, the sun is bright. Feel the heat? Hey. The sun is beating down all the time. Hey. I can't take this pressure, man.
Some people put solar panels on the roof to heat water to keep their house warm. Want to see how they work? Fill 3 bowls up with water like this. Then add food coloring to 2 of them so that they're really dark. Now, put a piece of glass over one of them. In a few hours, come back and see how they're doing. Not bad. Whoa, the dark water is warmer than the clear water. Solar panels are black because black absorbs the most energy. Just joking. This one's warmest of all. Solar panels are covered with glass because glass keeps in the most heat. It's science. It's hot, and it's hot out here.
This is Deep Yellow.
It's a supercharged bottle of gas. I'm talking about the sun.
Maybe you've heard of them. Maybe you haven't. But maybe you have. They used to be big, really big. They used to be called Cloudy Day, till they lightened up and became stars. Carlos Sonny Corona, lead guitar, and composed of so much helium that he only sang the high parts. Fanny Flare, she thought the solar system revolved around her. It did. Bonnie Brightlight, one of the hottest of them all. She had a temperature of 6,000 degrees. And Lenny Sunstroke Metalhead, once one of the brightest stars anywhere, although he was briefly eclipsed by a guy named Moon. Well, have you heard enough yet?
Well, that's our show. We've had our day in the sun. Burned up all our time. Hope you feel a little brighter. Do excuse me, I've got some solar prominences to investigate. See you after the next sunrise.
Produced in association with the National Science Foundation.
Action. The sun gets its energy from continuous explosions.
Здравствуйте, молодые друзья! Солнечная энергия постоянных атомных взрывов, которые получаются при падении вот этой ракеты.